Hello, ladies and gentlemen. Here we have with the explanation of assignment F. Now, the equations in this assignment are these three, and it depends on what type of object you're looking at, what type of system. For strings, F sub n is equal to nv over 2L. Now, let me get this straight. F is, whoops, let me go back. Sorry about that, guys. Let's go ahead and get my pen going. Well, let's keep it with red. So what F sub n is what we call the fundamental frequency. And if n is equal to 1, it's called the fundamental. And if n is equal to 2 or more, we're talking about the harmonics. And remember, harmonic frequency is frequency that looks very similar to the fundamental, but it's a little bit higher in frequency, but they kind of meet and end in the same place. And so n is the order of harmonic. V is the speed of sound, or the speed of the wave. Now, if we're talking about piano string, it's how fast the wave is vibrating back and forth on that string. And for the pipe, it's basically air. L is the length of the pipe. Length of pipe or length of string, depending upon which system we're looking at. So all the equations are very similar, but it's what we're looking at. For the V here, the velocity, it's actually the string. And for V, it's actually the sound in air. So there's the major difference between these two. Even though the equation looks exactly the same, the variables mean something a little bit different. And it's up for you to realize which equation goes with which. For open pipe, very similar to a closed pipe, but now we have 4L. And remember, we talked about that in the lecture portion of this class. Now let's figure out how we're going to do this. A piano wire vibrates with a fundamental frequency, so F sub 1 is 440 hertz. The speed of sound on the wire, so the speed is now 550 meters per second. And we want to know what L is. So the fundamental frequency is equal to n times velocity over, since this is a string, it's going to be 2L. N is 1. Velocity, so n is equal to 1. We're looking for the fundamental frequency. 1 times v over 2 and L. So let's see. We're looking for L. Multiply both sides by L. So F times L is equal to nv over 2. And let's drop the frequency down, divide both sides by frequency. So length is equal to nv over 2 times the frequency. So let's put the numbers in. Length is equal to 1 times the velocity, which is 550, divided by 2 times the frequency, which is 440 hertz. So the speed must be in meters per second, and the frequency needs to be in hertz per second. So the length is going to be 1 times 550 is 550, divided by 2 times 440, which is going to be 880. And we're going to get a length that is going to be 0.625 meters, or 62.5 centimeters. So this is a fairly long piece of wire, but this is what I'm looking for, and this is what I'm looking for to solve these equations. Have a good day, folks, and hopefully this makes sense to you. If you have any questions, please Zoom with me or email me. Thank you.